And we're back. And it's COMP1011. It's week 6, lesson 6, part 2. And I just kind of mentioned about the exam. It's going to be next week on, again, the same time frame, this 3 o'clock period. I'm probably going to give you about 2.5 hours or so to do it. You're going to have a practical, something to build that's practical. It's going to be worth 20% of your mark, right? And I'd ask you to please arrive on time. I know some of you are here already, so it's cool, but there's other people that aren't normally here or they have other things to do. So that's what's going to happen for next week. Any questions around that? And again, the same time next week, your assignment 3 is due on the Friday, right? So if you finish early, we might have a chance to talk about assignment 3. I might have a chance to look at it a little bit. If you have questions around it, I can probably answer some of those questions before you go. I suspect that most of you will be done within the 2 hours, not 2.5, because I'm not going to make it. I'm going to time it for around 1.5 hours range. Some people might need a little more time. I'm not going to make it so that it lasts the whole 2 hours or 3 hours that we're here together. So if you're good, we may end off a little early. So now what I want to do is I want to talk about this interface stuff and how to override my built-ins that we have. So we just kind of did this object is equal to my object is equal to new object. That makes sense. But this object doesn't really do anything. If I actually implement this right now and I go my object.toString, this actually returns something, right? This object's never really used, right? So if I sit there and I go in here and I have to kind of generate a variable, right? Let's say I want to talk about this as a string. So I go string, and I want to make this the of type string. I'm going to say my string, right, is equal to my object.toString. Can I do that? Huh? What do you think? Okay. And if I've got my string, right, can I then do a system.out.println, right? And can I kind of output my string? My string should actually be something that I'm getting from my object, right? My object has no value right now. But if I run this thing just the way it is, I get java.lang.object67327b6. What is that? What am I getting here? The object name. This is very important because each of our objects have this property. We can always go and do a toString and take the object value and output it, right? But what if I want to use my toString, but something making it more contextual for my object? Like, for example, if I make the car class, right, like we did last time or a couple times before that, right? And my car class we did for our test, right? I want to take my car class for my test, but I want to, instead of have a show method, we always do these show methods. I want to override the built-in toString method and make it so that it prints out stuff from my car class, right? Well, let's rebuild this string really quickly for this first part, and then we'll get back into UI, okay? Because I think it's important for us to do this so I can help you with your test, your assignment. All right, so first thing is this. Let's leave it the way it is for now. I'm going to implement a new class, right? And just for this example, right now, if I click on, take a look at this. Inside my class, if I call it the vehicle superclass, right? And I make it abstract, I can click on abstract here, right? Here's abstract, right? And I can also say I have my constructors for my superclass or whatever, but I don't need all that right now. I'm press finish. So here's an abstract. It does it all for you, right? Look, public, abstract, class, vehicle. There's my outline. Vehicle actually should be, if I go back, I should be able to refactor the name of this thing, because I don't want to think, I think vehicle is incorrect. It should be capital V. I forgot to do that. So how do I fix that? How do I make it so that the class itself, the name of the class, I want to rename this thing. So if I go refactor, rename, that's the way I do it, right? Here in Eclipse. And I name it from vehicle, lowercase v, to vehicle, uppercase V. That's the first thing I can do. And it says update references, update similarly named variables and methods. I don't need to do that right now. update contextual occurrences and comments and strings. I haven't done any of those yet, so I can skip all those. Okay, cool. I've renamed it the vehicle class, and if I double click it now, my class name has changed to vehicle. I should do those things because our classes should all be uppercase, right? Or camel case, if you will, upper camel case. All right. Well, I need a constructor for this thing. So obviously, I'm going to do something like this: public void, and I'm going to call my constructor vehicle. Right? That's my constructor. And right now, it's kind of like I've overridden the empty constructor. That's what comes with my class at the beginning anyway, right? And I haven't done anything in there. So this is my constructor. Let's put some, some comments that says this is constructor. And again, this is the way we're going to be doing it, right? We're going to kind of comment in here. All right, and then on top of the constructor, what I want to do is I want to put in some instance variables or fields, right? Now we know that we have a couple things we can do. For example, in my car, this is instance variables, right? Or I'll say fields. You might want to call them one or the other. It doesn't matter. They're the same things, right? You'll hear them mentioned both ways. So I want to call them private because I think that's important for us to explicitly say that they're private. And inside these private fields, let's say we definitely have a wheel count or a tire count or something like that. So maybe we'll do a tire count this time. Tire count. And we need to give it some kind of variable, data type, which is probably going to be a type int, because I think integer is probably the right type for tire count. You can have tires that are a half a tire, right? So you can't have doubles or something like that, right? And I remember from our convention, we're going to start using the underscore in front of it. So when I say tire count, it's going to be underscore tire count. The underscore before the name is our new convention for private member variables that we're going to be using from here on in, right? Okay, cool, cool. And now I want to create from my tire count a very simple property. So I'm going to right click onto this thing, right? And if I go to, if I want to create my this stuff in here, how would I refactor it? Well, I can just say, I can extract the interface, I can extract the superclass, right? I can encapsulate the field, right? How do I create this automatically? Do you guys remember which way to do it? Quick fix. Quick fix. Create getter and setter, right? It does it automatically for you. If I double click that, and it says, what do you want the things to look like? Here's my get tire count, and here's my set tire count. Well, these getters and setters, in fact, it does encapsulate the field, right? And I'm going to probably say, I'll leave it the way it is, and I'll say OK. And when I do that, it brings them down here, right? These getters and setters. But remember what I told you. I want you to put these getters and setters kind of at the top, just from a framing perspective. I want you to frame them up here, right? It's automatic, right? It does it all for you. Look, public int. So here's my private, and here's my public. Well, if I want to keep them the same name, and sometimes from a get tire count and set tire count, I'm going to undo this change for a second. Let's just go back and do this again. All right. Let's just click undo, and go back. I want to encapsulate. I want to go to refactor, encapsulate the field that I got there, right? So refactor, and it says encapsulate field. Right, and now it gives me getters and setters, but instead of get tire count and set tire count, right? Let's do one thing. We know tire count is with a lowercase t with an underscore, right? Let's just make it so that it looks good. I want to make it so it's capital. So I want to say get tire count, right? And set tire count. That's what I want it to look like. And the reason for that is because from a conventional perspective, I want my getters and setters to have a capital in front of them. Let me just show you again. Now look what it says. The name is discouraged. According to convention, names of methods should start with a lowercase letter, and this name is discouraged. According to convention, names of methods should start with a lowercase letter. Both these things, because in Java, right, all method names are lowercase. This is good. This is what I wanted to show you. Right? If I go back, Because my default was a get tire count lowercase and set tire count lowercase. That's my default. Does that make sense? You ever seen that before? No? Didn't pop up for you? So now my getters and setters are like this. They look like this. Now if you're following along, you can do it your way. You can name them whatever you like. Again, this is just for demo purposes more than anything else, right? Okay, one thing I should do, because we're working with people who are remote, I'm going to open up a GitHub repo right now just for us, just so we can follow along. So I'm going to call this COMP1011, and it'd be lesson 5, right? 6. I'll be okay. Lesson 5 was last week, but we kind of did the same thing as the week before. All right, and we will copy this one. I'll go back into Eclipse. And in here, into my lesson 6, I'll right-click and go to Team, and I'll go to Share Project. So, have you guys with me on Share Project? It tells me which one, CVS or Git. I want to say Git. And I'm going to say Use or Create Repository in Parent Folder of the project. And I'm going to click the project and say Create Repository, and click Finish. When I do this, it has its own little project folder, if you notice. Lesson 6, and it says No Head. No head means I need to make a commit. So I'm going to right click, I'm going to go down to Team, I'm going to go to Commit, and inside my commit it says my vehicle has changed. Do you want to save? Yes, I do. Right? And I'm going to say, I'm going to call this graded vehicle abstract class. Right? And I'm going to kind of hit all these ones because these are all the ones I want to save. Right? And then press Commit. If I could click Commit and Push, it'll do the same thing, but it'll ask me for the repository, and this is it. Look, it picked it up when I copied it from GitHub, right? And I click Next and press Next again, and then Finish. What it'll do is it'll add everything to the remote, and when it does that, if I go to Home and refresh, it'll have everything here, my source and everything else that we've just been working on GitHub, so you guys can follow along. Remember, GitHub is my friend, right? That way we can, if I mess something up or if you don't know what I did, and if you can't remember, you can go back to GitHub and see what I did. Okay, so let's just get rid of some of these basic my kind of these stubs. This just tells me what each of these things are. But what I want to put in here, at the very minimum, when we do our tests, when we do our assignments, is something like this. Properties, right? These are our properties. And I'm sectioning this off so you can understand how things go. Here's my constructor, here's my instance variables, here's my properties. And you know what? This is cool. And this is all abstract. This is all part of my abstract class, right? I'm going to save this thing. One thing I want to do is add a method, right? I want to override a method that exists in my object superclass, right? Now, this is where I need your help, guys, because you guys are smarter than me, right? I want to know how to do this. I want to override public method toString, right? Methods here are lowercase. The toString method that comes from derived from object superclass. How do I do that? Derived spelled wrong, I bet you. Hold on a second. I'm gonna follow what you told me because I want you guys want. So is it public first? Is it at override first? What do I do? At override, right? So let's do this thing where I go at override. I press Control Space at override, and then what do I do now? Right away or under the next line? At override, and what do I start? Public. Yeah. And then toString, right? The way it would normally work, right? Is that right? Oh, with a capital S? Okay, sure. Does that make sense? Hey, but it give me an error here. It says add return statement. Oh, hey, I need to add a return statement. Okay, so it's going to return. This is what I'm going to return. it's going to return my tire count. It's going to return this get tire count thing, right? But I'm going to return tire count. So I'm going to say return. Here's the string. The vehicle has num count. So tire count. So this dot tire count, right, plus tires. Make sense? Will this work? Can I do a toString now in my program? Right? Well, first of all, I can't instantiate an abstract class, so let's create our car class that we're going to instantiate. But before that, you know what? I think we should instantiate an interface as well. We should make an interface. We should try to create one. That's very simple. So that way it gives you all you need for assignment number 3. Then we can stop, right? Because this will kind of be a reminder of what you need. Okay, so I'm going to go right-click, New, and then we're going to go Interface, right? And the name of the interface is what? And then something like, if it's a car, what would I have that's different in a car than a truck? If I was going to do a car or a truck, vehicle can also be a train, right? That's a train too. A vehicle could also be something else, like a spaceship, right? Could be a plane. I have wheels. Well, even a spaceship has wheels to land, right? Theoretically, right? I have tires, right? Engines. Huh? For just a car. Just a car. Let's say if the car was going to interface, we have to force it. Yeah. What do you think, Sean? What was that? A trunk? So carrying capacity, right? Like storage capacity. I have storage? Okay, so maybe I have storage? Okay, let's do that. So I'll call that I have storage is what we're going to make. I have storage. It's going to be a public modifier, right? I don't want to generate comments yet, and I'm just going to create finish. Here's my interface. I have storage, right? Okay. I want to outline the public type of, well, we may not have to do this in a second. I want to return a type of a Boolean variable, right? That's what my return type is going to be. So if I start just typing things like have storage, here's my have storage method, right? I have to produce some kind of, if you look at the quick fix, if I hover over this thing, it says one quick fix, set method return type to void, okay, but I don't want to return void, I want to return bool. Let's try void, so at least I have to do this. This is the bare minimum. So I want a kind of a Boolean return type, right? And if I look and see what it is, right, I could create class bool. I change to Boolean with a capital B, that's the one I want, right? Does that make sense? What am I saying here? That's all I need for my interface, right? I don't describe my method in my interface. Never describe it. All I do is outline what I want for my car class to include. I have storage, right? So now when I create my car class, I have my interface and I have my abstract class. And let's make one more interface for a truck, because I want to make a truck class as well, right? So let's go right-click, New, Interface, and this time it's going to be called I have what? We did a truck has storage, so does a car has storage, but a truck does something else. Yeah. Flatbed? How about something else a truck has that a car, or maybe a train? We'll do a train. Something totally different. I use rails, right? I use rails, right? Train uses rails. Car, no. I use rails. I use rails, right? I'm going to finish this off. And let's do one more, right? Just because of that same vein, new, right? New interface, right? I'll go, I use roads, right? Interface. So I use roads, I use rails. and we're going to define in the I use roads, we'll say, again, it's if I use roads or not, right? I'm going to check to see if I use roads. If the only way I use roads is if I have tires. Wait a minute, my train, it doesn't have tires. It doesn't have a tire count, right? That's an issue. I'm going to have to change my abstract class in a second before I go back, before I can rate my train or my car, because they're both vehicles, right? But I use roads is going to check to see if I have a tire count. So if tire count is greater than 0, let's say, as an example. And that's how we use roads, right? So I'll say it's definitely a bool that I'm going to return. So it's Boolean, again, and then I use roads is going to be the use roads method that we're going to define. We're just outlining this, that's what's required. So again, interfaces, remember what they do is they help us shape our classes. They don't really do anything other than that, right? You could include a fully fleshed out other things in here. But for now, let's keep it simple with interfaces so we understand them. Here's I use Rails, the same thing. I want to make a Boolean, right? I'll make it a Boolean type of return, right? And the thing is going to be, well, I'm going to use Rails, but if the thing uses Rails, right, I'll say that. I'll say, you know, use Rails, right? So I use Rails, I use roads, right? Make sense? And we'll check to see how we can incorporate this into our design. So we have three interfaces. Here they are. And look how they're spelled out in Java. 1, 2, 3. With the I tells us it's an interface, right? The regular, this symbol here is as of a class. These are like question marks here, right? And if I actually look at the my subclass, which I'm going to create now, we're going to create two subclasses. So I'm going to go new class, right? And now see here at superclass, I'm not going to pick my object as a superclass anymore. I'm going to go browse, and I'm going to choose vehicle, right? Vehicle for my superclass, right? Here's my vehicle superclass. There it is, right? And I'm going to also use interfaces in a second. Here's my interfaces. Look where it says add. I can click add my interface. I can search for I. Here it is. I have storage, right? From my car class. This is what I'm building. So I have storage, right? And we'll call the class car. That's what the name of the car class is. So here's my I have storage interface, right? And I also use roads, right? So I'll go I use roads. There it is. I use roads, right? Couple of them. Doing this all in the when I create my class here, right? And you know what? I want my constructor from the superclass included. Why not? Right? And I also want to inherit my abstract methods. I'm clicking on all that stuff because I have some abstract methods I gotta inherit right now if I have any. And press finish. Bam. Okay, it gets made. Look what I got. I got my public car class. I've got an override from my Boolean use roads and an override from my Boolean have storage, right? Right now. All pre-done for you. And look what it says here. My public class car extends vehicle, that's my superclass, and implements I have storage and I use roads. This is what I need you to do for your assignment 3. Okay, it's very simple. So now it means automatically that I have these things being used, right? And if I want to use some other things for cars that are different, like for example, for returning Boolean for have storage, is if my car is big, I can actually have some other instance variables. Let's just outline them now. So here's my only instance variables available to my car. So instance variables, right? And my car, if I have storage, as an example, can check to see if I have a trunk, right? So I'll make a Boolean private Boolean variable with an underscore. We're going to say trunk, right? And of course, when we create our car class, we're going to ask for if it has a trunk or not. So we're going to go Boolean trunk. See, I'm not using the underscore, right? I'm taking that in. And inside my constructor, I'm going to say this dot underscore trunk is equal to trunk, right? So right there, I set my trunk, whether it's true, whether I have a trunk, true or false, for the car. It might be a small car, there's no trunk, right? I don't know. And if it's true, I can check now to say if. Actually, let's do a ternary operator here. Do you guys remember how to do a ternary operator? Oh, I'm going to challenge you guys today. So instead of returning null, right, for have storage, I'm going to return it like this. I'm going to say this dot trunk, right? This dot trunk, question mark, true, right? Thing, false. Do you understand this notation? Yes. It's called the ternary operator, right? I'm checking to see if this dot trunk is equal to true, right? And if it is, if you want to be explicit about it, you can do one of these to make it easier for you guys to understand. Is equal to true. And then if it's true, then return true. If false, return false. So I don't have to say in 5 lines, if this underscore trunk is equal to true, and in brackets, then call it return true, and then else return false. That's how much lines I would take out. I would take like 6 or 8 lines to do this, and I could do it in 1 line. Make sense? Do you guys get this piece?
But so we have to have it equal to true, and then we check for true or false? Or?
I don't have to, because if I just do this trunk, I'm checking to see if this exists as true. But however, I'll leave it like this so you guys can see it. Right? This notation and the other notation are equivalent. The way it works is this: condition, the condition, a question mark, the true condition, and the false condition, separated by a colon. Okay? So that's the have storage. And then use roads, I can do the same thing, right? I can get rid of this and say, well, if my tire count, oh, do I have access to my tire count? Yes, I do. Because if you remember, I can do this dot, and if I say get, I can't do get tire count, but I can do get tire count, right? How do I access my base class's get tire count? How do I do that?
You can't because it's private.
Whoa. Hold on a second. Wait a minute. Here's my program, right? Here's my vehicle. I have these getters and setters, get tire count and set tire count. How come I can't access them? But they're private. Who the hell made them private, man? They should be public, right? If they're not public, that's wrong. So I should be able to see those in my car class, right? So if I say return get this dot get tire count, right? I should use these things because that's what's available to me. This dot get tire count, right, is what I'm returning. And if you notice, it says, hey, there's an error, right, because this type is mismatched, right? I cannot convert from int to a Boolean. So I want to say I can make a thing. So I can do this. Get this dot get tire count, right, is greater than 0. Here's the word the ternary operator comes in again, right? Question mark, true, otherwise false. Yeah? 1 line. Are you seeing this? Condition, question mark. The true answer, colon, the false result. Which one would it be, right? And you don't have to do true and false. You can either do other kind of conditions and other kind of things. It's called the ternary operator, and I want you to use this thing when it comes to only 2 conditions. There's only 2 possibilities, true or false. Ternary operator is your best choice. Here's 1 line, right? It's a very common syntax. You'll see it everywhere, okay? Whenever you look at different languages. Some people hate it because they're like, it makes no sense to me. Why are they using this thing? It's not clear, right? And other people love it because it only takes up 1 line of code instead of 8. Right? So I want to introduce it to you so you're going to need to do it on your exam. I'm going to ask you for the ternary operator since I'm talking about it today. Right? So if you don't know how to use it, you're going to have issues. Okay, ternary operator. I have storage now. So this kind of satisfies these conditions. It's going to return true or false, right? And I've kind of finished off my car class. I'm going to close off these interfaces here because I don't have to use these right now. Let's create my train class. All right, so I'm going to go right click. I'm going to go new. I'm going to go class. Okay, let's call it train with a capital T. I'm going to also browse, and instead of my object superclass, I'm going to get the vehicle class. Here it is for my default package. I'm also going to add a couple of my interfaces. One of them is I have storage because the train can have storage too, and I can also have I use Rails. Right, so here's my I use Rails, and I add that in as well. So I have storage and I use Rails. I want to get the constructors from the superclass and an inherited abstract methods. I want to press finish. Boom, it looks like the other one, doesn't it? But now I have storage and I use Rails, and here's my public train, right? My constructor. And inside my public train, let's just do this a couple times again. I'll say here's my constructor. Right? And in my constructor, what's the difference between a train and a car? Well, you have a large passenger count, right? Well, we also have that in the car, don't we? Wait, passenger count, we have it in the car, we have it in the train. Guess what we got to do? Add it to the abstract class. Both things are happening. We're going to talk about it, right? So let's go back to the abstract class, which is the vehicle class, now that we're creating it, and we'll say private int. We can't have half passengers, right? Private int passenger counts, right? And you know what? I need to create my my encapsulation here. So I'm going to go to refactor. I'm going to say, sorry, I got to outline the right thing. Refactor. And I want to encapsulate my field. Here I am. And this time I want to say get passenger count. And I want to set passenger count because I want to do both, right? And they're not going to be private. They're going to be public, right? So I'm going to set the access modifier to private, public, and press OK, which is what I should have done for the other ones, right? Okay, so here they are. So here's my public, my other couple fields. I'm going to cut these ones out here and put them where my properties are up here so they're the same. And now I have two more accessor methods, right, from my properties, from my fields, right? And they're allowing me to access my private property, my private instance variable with my public properties. Remember, convention, private instance variables, public properties, public methods. You also have some private utility methods that we like to use right within our coding as well. Okay, cool. So again, set tires. And again, I'm trying to circle back with you guys on properties because we kind of did them, but I'm circling back down. I'm making you use them because we really haven't used them so much before, and I'm going to make you use them all the time from now on. And when we do Android programming, you're going to use more properties that are like this, encapsulated properties, than private properties, private instance variables that we see up here, so to speak. Just going to answer my wife really quickly because my son has all kinds of sickness. I'm staying home tomorrow, baby. Yes, my love. Okay. So this is the properties and variables of the vehicle class. I just added a couple more things, which means because I added them to the abstract class vehicle, right? Well, guess what? Now my car and my train have access to those things, right? So I only need them for my train count. And what I'm going to say is this: if here's where I'm going to check now. For my use Rails, I want to make sure that my storage, my capacity, I definitely have storage, right? I know that I have storage, right? And I'm definitely going to use Rails, that's for sure, 100%. But I'm going to check to see if for my train I have my capacity is bigger than 10, let's say. So I'm checking if my number of passengers is greater than 10, then I can use my rails. I can use my train. If not, then again, it's just something we're checking. It's a silly thing that we're asking for, but it's just something that we're checking, okay? So we're going to say, instead of making it if, then, else, I'm going to use a ternary operator here. I'm going to say, if my passenger capacity, get passenger count, if my get passenger count is greater than, let's say, 10, right? Then, that's the question mark, it's true that I need rails, right? Or else, it's false. We won't use the train, kind of thing, because we have less than 10 passengers. You can probably fit a few passengers in a van, right? As I say. I can make this smaller to like 7 or whatever. Okay, and we did the same thing for I have storage, right? I say if this trunk is equal to true, right? Well, my train doesn't have trunks. We're going to go up here and we're going to create another private instance variable, right? So here's our instance variables for the train. And what do we call the storage? We have a storage compartment on the train, right? That's what it is. So we're going to say private storage compartment, right? And of course, it's going to be of type Boolean. Do we have one or not? Right? And we're going to make it, because it's private, we're going to put an underscore, because it's tell us it's private. And we're going to ask for it here. We're going to say Boolean. We're going to say, in this instead of storage compartment, we're just going to say storage, right? Just to make it easier. And we're going to say this dot underscore storage compartment is equal to storage. And down here we're going to say the same ternary kind of operator we're going to use here. We're going to say if, think about using the, almost like saying if without using if you know, this dot underscore storage compartment is equal to true, well, we know then that we're going to return true, oops, question mark. We're going to return true, otherwise we're going to return false. That's the shorthand. It's called the ternary operator. Make sense? We've got a train class. We've got our, hey guys, we've almost done our assignment number 3. Right? So why am I doing this stuff with you? Because I want to train you to do your assignments and I want to train you to do your exams. It's not because I want you to fail or get low marks. It's not about that for me at all. It never has been. It's all around, let's make sure you understand what to do, right? And you know how to create classes. And they're done in Java. It's done really nicely. You can create them all nicely for you. Now let's implement them. So we've got the classes. All right, and you know what? Let's implement the first one. So I'm going to say car. We're going to call it my car, right? Is equal to new car. Well, guess what we need with the car? We need a trunk. Does it have a trunk? True. We're going to send true. It has a trunk, right? It has a trunk, right? And we're going to say train is equal to small train. Right, is equal to new train, and you know what? The cup that doesn't have a compartment, right? Okay, so let's go back to our train class. Here's our train class for a second. This is all good and everything else for train, and we have some public properties here. Which, by the way, if I was going to redo these again, have storage and use rails. These are methods. So I can put in here, I would kind of, from a commenting perspective, I would put something like this for perfect marks, right? So something like methods, override methods, right? Just to show that these are the ones we've overridden from our superclass or whatever. And then these do things, use rails and have storage, right? Which is a good thing. And the same thing goes with our car. Here's our car class, right? You want to kind of put a comment that says, you know, override methods. I know I'm killing it here. Like you guys are going to, come on, Tom, how come you're doing so many comments? Well, but that's how we do it, right? And same thing with, I forgot to put the constructor here, right? Okay, and now we're going to implement the two. We're going to test out that my car has a couple of things here. My car dot, I'm going to try and use the toString method, right? Because here's my toString method. That's the one we overrode from my superclass, right? Let's use that. And of course, I can't just do this. I gotta kind of use it. It's an output. It's a string, right? So I'm going to do this. I'm going to say system.out.println, right? And I'm going to output the value that I get from my toString out to the console. And the same thing, I'll do the same thing for my small train. I'm going to say system.out.println. And does the small train have, oh, I didn't do it right. Small train have, you know, I want to get a, what's going to call it, have storage. I want to see if it has storage. And we'll say does my train have storage? You know, whatever, some kind of message, and then small train have storage. Right? And this is car my string. I'll leave that the way it is. And let's see what we get when we actually run this thing. Bam! The vehicle has 0 tires because I haven't given it the tires, right? If I want to set the vehicle tires, I can set them here. The only way I can set the tires is by using the setter. So I can say my car, that's why I set it up, set tire count to 4, right? I can do that. And when I run it again, I get 4 tires. Does my train have storage? No, it's false, right? My train does not have storage, right? And my vehicle has 4 tires, right? Do you guys get it? So again, what I'm doing here is I've got an abstract class and I've got a vehicle class, and we want to try, and this is maybe not the best example, the planet example is better, but we want to use abstract classes if we want to derive other classes from them in a game environment. And I know Louis is he's our guest today, right? I put it on YouTube so everyone knows Louis. From a game perspective, what we do is we make a super object, a super game object, if you will. We're going to do that in our game class, our COMP1011, right? And a lot of times we make this abstract superclass our game object. And what we want to do is we never instantiate from it. What we do is we create subclasses from it. Player, enemy, bullet, shield, whatever we want to make. I can do that. But first we make our super duper game entity, right, which we use, and we use that as an abstract class to derive other classes from it, right, as an example. And this is a great example of that, how we would do that. Now, car, this is a very simple example. I'm just going to update my GitHub here. So I'm going to go to team. I'm going to go to commit, and I'm going to say added 3 interfaces and 2 subclasses, right? I'm going to kind of hit everything here and press commit and push. There we go. And now if I want to look at my GitHub page and refresh, if I go to source, I have all these things there. So you guys can see all those things if you wanted to follow along. And this is a great example for you guys to use for your exam next week. So if you don't know how to do stuff, you can always look at GitHub. Right? You can know it's open book, right? I'm going to discourage you from using Google. There's no Googling next week at all on your exam. It's a final exam that's worth 20, right? Or a midterm exam that's worth 20%. So no Googling, but you can use GitHub because I'm giving you access to your GitHub, my GitHub, your assignment 1, 2, and 3. You can access those things, those resources, and any PowerPoint presentations that we use. Okay, so I'll stop recording at this point.